everyone, welcome back to my channel EduVibe. Today we will start with the forces and fields, introduction to magnetism. So we're doing the unit and we are on the last part of this unit. Today we'll start that part. So this is the magnetism. All we know, we'll learn about the magnets, how the magnet works, how the magnet feels, lines, equations, and some rules they have to get the magnetic field lines. So this is more on the theory based part, and we'll do one equation to one the formulas too, and we know that how can use this formula too. So basically it's more like a theory based part. So let's start with the magnet and introduction of the magnetism first. So this one. So if you ever try taking separate magnets and bring them together, there are two possibilities. The magnets will stick and quite willing, or the magnets are difficult to get near one another. So we all know that this is the magnet's property to do the attraction or the repulsion. So they do the two of things. So they do repulsion or they do attraction. So when they do the repulsion, when they do attraction, so they are the two similar principle of that. So if the like magnet poles, so the light magnetic pole means if the south and south or the north and north go into each other. So they don't attract to each other. Either they do the repulsion. They do repel to each other. Like if we do north and north, and if we do south and south, so they do the more likely repulsion. They do not that attract. They do not stick together. But if we do the opposite magnetic poles attraction, which means that we do south and north, or the north and south, so they do the attraction. They will stick together, which I mentioned over there. Either they do attraction or they do the repulsion. So that's the two things they do when we put the two magnets closer to there. So that's all thing known as the law of magnetism. So this is based on the law of magnetism which we do today. So all magnets have the two poles, which are the north poles and north poles. We all know the north pole and the south poles are the two poles in the magnet. In that type of magnet, this is like a bar magnet, and we have that horseshoe magnet too, and different kinds of magnet. We have the all the magnets have the north and south poles. So one thing in this, when the question is asking in this, that when we break the any like we break like this is a magnet and we break that in two parts. So what will happen? The north part separate or south part separate, or something else will happen. So that's the question over there. What happens when the magnet will break a bar magnet? So that magnet will still come with the two poles. So if there's magnet and we break it into two parts, and the two parts separately made the north and south pole again. That's the property of that. When we break the magnet, they will get the two poles still they have those two. So that's the thing you have to know in this. So now, as we do the electric fields, so this also we also have the magnetic fields too. So magnetic fields, what they have, like the magnets can exert a force on the magnetic objects. So all of that, like iron objects, they attraction that those are to the magnet. They will do the attraction. They will do a magnetic objects to draw to each other. These forces do not require the physical unit. They do not require a physical unit. Either they are like a uh, on the same field they have, they go the attraction. And magnetic object is surrounded by the three-dimensional magnetic field. So this is the type of the magnetic field, not that. So this is the magnetic field, this is the magnetic field lines, and that all you can see from the magnets they going out. So these are the magnetic fields. So the symbol we use for magnetic field is B. So if this is again the vector quantity, so we put the small arrow on that. And the unit for this is the Tesla, which is denoted by the capital T. So that's all the magnetic fields. Now, as the magnetic fields have both the magnetic direction, it's a vector quantity. So that's all. So how the magnetic fields can be occur? So from here, if we know that how they can be made, so the field leaves the north pole of the magnet. So you can see this is a north pole and it leaves that. You can see the arrows go out. The leaves that all the things, the leaves from here, you can see the leaves from the North Pole, and the field enters the South Pole. And you can see they enters the South Pole. It goes from here, it go pro full circle and goes in. Again, they do like this. So all the poles are originate from the North Pole and goes to the South Pole. Like that kind of thing, they travel that distance, which makes the magnetic fields. And how this direction happens when we do with the compass. So although that the compass is the thing which we have, also we have the north and south pole. So the direction of the magnetic fields, the north needle of the compass are the test object, will always point in the direction of the magnetic field at that point in space. So you can see the compass. When we see the compass, the north needle always going to point to the magnetic fields. So this is the north thing. So the red part, the red half of the needle, and it is the north pole of the compass. So that red part always the north pole, and if you see the black one is also the like north pole direction, and the white part, this white part is the south pole direction. So you have to know that this is the red part is the north, or the black part is the north, and the white part is the south pole. So magnetic field lines will start on North Pole and end on the South Pole of the magnetic object. Magnetic fields are directed from the North Pole and South Pole of the to the South Pole of the magnetic object. That's all thing we know in this. So how the magnetic field lines depend on the direction, how they follow, which direction they follow. We have to basically know this. This is known as magnetic field lines too. We all know that. So magnetic fields, if we are inside the earth, they depend on the like kind of objects when we do. So it's the like other thing we do. But in the earth's magnetic field is like a other concept. Like something is different in the earth's magnetic field. So what is that difference? So the earth's magnetic field is relatively weak compared to magnetic fields. So if we're talking about the earth's magnetic field and we're talking about the only magnetic field, so the earth's magnetic field is weaker than the magnetic fields. So the north needle of the compass points on the Earth's north pole, as we all know that north needle will point to the north pole of the Earth. Magnetic field and the Earth acts like a giant bar magnet. If we're talking about the Earth's magnetic field like this, Earth's magnetic field acts like a giant bar magnet with approximately around very giant. So for this, if we know about the geographic north or we're talking about the geographic south, so geographic north like this over there. Wait. This is geographic north. This is called the geographic south pole. This is a magnetic south pole. So geographic north is called the south pole, magnetic south pole, and geographic south, which is this, is called about the geographic north pole. So that's the reverse thing. Geographic north is magnetic south pole, geographic south is magnetic north pole. So that's the Earth magnetic field is different from the simple magnetic field we are talking about in this. So that's the difference. This is the main difference we are talking in this. And the other planets also have this different kind of magnetic fields. We don't only Earth in this. This is like a thing you have to just know, not for like a assessment phase. So this is what you know. So for example, we get these type of examples. We determine the direction of the net magnetic field at P, the bar metal of the equal strength. So all the bar metal of the equal strength, we made the magnetic field for the P point. What is the direction they follow? So as we do in the electric fields, we add that P point when we get. So we always tell that the P point always has a positive charge. In that case, when you get that P point in the magnetism, we denote this as this is the north pole always. So this is remains the north pole always. So if that north pole attracts to this, if they like closer to that north pole, so what they happen? So they do the repulsion. So they do like this type of repulsion. If this goes to this south pole, what will they do? They do attract to that. They do repulsion in this, they do the attraction in this. If that goes with this, again they do the repulsion in this, that thing that goes. So they go over there, they go over there. Or if we made a field in this, so if you raise that, go over here, they over there, or they go over there. That thing, that type of triangle you get. So what's really happen in this? So if the P point is your north pole, so they go between that two south poles. So they do that south pole attraction, and the magnetic field goes like this. So that's the thing we all know. Yet how can we make that? This is a vector kind of thing we made in this. Like that goes on, this goes up in that case, and the magnetic field goes over there. So you have to find the net magnetic field where they goes. So that they goes. So that's the thing you have to know in this. For the next one, we have to make the magnetic field lines in the area between the two bar magnets. If we have to stretch the magnetic field lines in the area between the two bar magnets, that what is that? How can we made? So if we have that south pole, and this is the north pole, north south. So north will not be like attracting to each other. They do the magnetic fields. So what will we do actually? That north pole originate the magnetic fields like this, and they go like curves thing, and they go over to south pole. If they originate from this, they go to like this. Same with this, they go from here and goes to the that thing south pole. But they didn't like attract to each other because the north didn't attract. They do repulsion. So this type of attraction, this type of direction they follow, and we made the magnetic field in this. So that's how the magnetic fields of the two bar magnets shows. But this shows in this. This shows the repulsion of magnetic lines. We also know that if the north do the repulsion, their lines, their field magnetic field lines also do the repulsion because of two north poles. So that's the thing you have. That's how the magnetism works. So we're just doing the introduction part today. We will move on to the rules of that, how the magnetic fields, how can we see that, how can we like tell that how the magnetic field direction will go. This is like the part we do in the like small type of magnets. But if we have like a thing we have, if we involve the force in this, and if we involve the electron charge and all the things we involve in this, so how can we tell that what is like magnetic field goes in? So that's all we have to do in the next video, next lesson. So learning myself where I do vibe, learn smarter but not harder. Please like, share and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.